which is 78. I mean, another way of looking at it, but what you've done is correct. It's the same what I'm saying.
Yeah.
Yeah. So this is a ratio problem. So 13 by 32 is the ratio into total will directly give the answer. Absolutely correct. Let's move on. Okay, 25 seconds. So this is directly 85% of 60, right?
Yeah.
And you did approximation.
Mhm.
Yeah. Okay.
Would there be a better way to do this, or this is probably the best?
If the answer choices are close enough, then I would have had to calculate, which will not take time.
Okay.
So
But for that, you can use a calculator, right?
yeah. But for instance, this problem, right? So, and this is the case with any percentage problem. So the way we set it up, and I think we'll solve more percentages later. You might need some practice there. So this is the question, right? Now, pair of shoes is costing $60. 60 and sale in which 15% off. So we learned the method of factors, right? Factors. Did we? So
I'm not
this
sure.
15% off is, can I say, on 100, I'm doing 15% off, right?
Yeah.
So this becomes my percentage. So 85% of the cost price is my new selling price. So this is cost price into discount percentage, which is 85%, is my new selling price. This is what is asked. So whenever you have these things which off or whatever, if you have increment, decrement, you just express them in terms of percentage, or this percentage you also know is 0.85.
Yeah.
85% means 85 by 100, which is 0.85.
Yeah.
And I know that 6 into 80 is 480, so the answer will be more than 48. So this is the answer. No need to use calci also. Because 6 into 80 will give you 480. So your answer has to be 51 only. There's only one answer above 48.
Yeah.
Yeah. Okay. So this is the best way to set it up. Something like this. Okay, let me see if I have another problem for this. Did we do such kind of problems?
Yeah.
Okay. So how would you solve this one?
You multiply A by, you multiply A by
It's simple.
1.2
Yeah, 1 point. Either you can take
and
it as
then
100 plus
0.8.
20%,
Yeah.
which can also be written as 1.2, right? 120%. So I told you directly use factors. And
Yeah.
decreases by 20% means 100 minus 20%, which is
Yeah.
nothing but 0.8. So using factors is fastest. So A salary first increases by 20%, then reduces by 20%. So 12 into 8 is 96. So 0.96 A. So percentage change is minus 4%. It falls by 4%, A salary. Original is this, so this is your base. And the new is this, right? So the change divided by the base is the answer. So
Yeah.
0.04 minus divided by A divided by A, base. So minus 4% is the answer. Yeah?
Yeah.
I have one more question. A trader gives successive discounts of 10, 20, and 10% respectively. What percentage of the original price he will recover? So how do we solve this? Let the original price be C. Discount of 10%, can I say factor is 0.9?
Yeah.
Discount of 20%, factor will be 0.8. Discount of 10%, factor will be 0.9 again. So when you multiply all these three, so this is 81 into 8 is 648. Which means the price has dropped by how much from the original? 35.2% drop. Because original is C, now the new price is 0.648.
Yeah.
Yeah. So the change, can I say, is 0.352 minus, and the original is C. So 35.2 drop.
Yeah.
Okay. Let's look at this one. A sells goods 30% cheaper than B and 30% dearer than C. By what percentage of is the cost of C's goods cheaper than B's?
What is dearer?
More expensive.
Okay.
Yeah. So by what percentage is the cost of C's goods cheaper than B's? So what is the base here? What are they asking? What do we have to compute?
I would do A equals to 0.7 times B, and then A equals to 1.3 times C, and
Okay,
then
so
you
one
equate.
method. Okay, one is the factors method. A is
Yeah.
0.7 times B, and what is? And 30% dearer than C. So
So A
A
equals to 1.3
1.3.
times C.
What are they asking for?
Uh, what percentage is the cost of C's good cheaper than B's?
What percentage is the C's goods cheaper than B? So what is the base? C or B?
B.
Yeah. After the word than is your base.
Mhm.
So B is in the base, right?
Yeah.
Okay. And what is in the numerator?
C.
What is in the numerator?
C.
So read the question again. By what percentage is the cost of C's goods cheaper than B's goods?
Or B minus C. Or C minus B.
Yeah, so C is cheaper than B, so it could be B minus C. Okay. So
Yeah.
if it were a ratio, then C by B. And suppose if this ratio comes to be 0.7, then you say, okay, C is 30% cheaper than B, correct?
Yeah.
So either solve it like this or like this. This is more difficult to conceptualize
Mhm.
and calculate. This is easier. So always try to get a ratio, and then you can determine whether it is increase, decrease, and by how much. So if you get a ratio of say 0.5, then you say, okay, C is 50% cheaper than B. If this ratio comes out to be 0.8, then you say C is 20% cheaper than B. So once you have the ratio, it becomes easier to interpret. And this is more difficult to calculate. B minus C. First of all, we do not know what these are, right? So
Mhm.
I will solve it using this method and then calculate what is required. Find the ratio and then calculate. For the ratio, I need the two entities. And for that, I need to understand what goes in the base and what goes in the numerator. Yes. So how do we
Yeah.
solve this?
Can you equate 1.3C and 0.7B?
Yeah,
And
you want C by B, right? But
yeah,
what is C?
yeah,
C is A by 1.3. And what is B? B is A by 0.7. So substitute in this. So A by 1.3 divided by A by 0.7. So this goes down, this goes up. You get 0.7 by 1.3. 7 by 13. And what is that? 0.538. So hence can I say C is cheaper than B by 46.2%. 1 minus 0.538, correct?
yeah, yeah.
One more way of solving is this. This is one way. Method 1. Method 2. I know the base is B. So I take B as 100. So if I take B as 100, what is A? 30% cheaper than B. So A becomes 70. And if A is 70, A is 30% dearer than C. A is 30% dearer than C. So can I say A equal to 1.3 times C, correct?
Yeah.
So what is C? 70 by 1.3, which is 53.84. So C by B is 53.84. Divide by 100. Same answer.
Mhm.
So I've shown you two ways of doing this.
Yeah.
Yeah.
Mhm.
Sometimes assuming the base is useful. Always start with, so if you're doing assumption of 100, always start with the base as 100 so that ultimately you need to divide by 100, right? So you directly get the ratio. So in method 2, your base has to be equal to 100. Here the base is B. Hence, we start with B as 100.
Yeah.
If our base was C, I would have started with C as 100 and then worked our way up.
Mhm.
Yes, so these are some other problems related to percentages. I will give you more practice sets to solve, but it helps to understand what is your thought process. I hope the plugging in method was useful.
Yeah.
Yeah. Okay, let's go to today's agenda, which is exponents and radicals.
There were actually three more questions in the
Oh, okay.
practice that you gave.
Okay, let's go through. Right. Okay, 3.5 minutes.
Yeah.
Brand new car is 33504, sales tax is 8.275%. What proportion of the total price of car after tax is the untaxed price of the car? So what ratio? Okay, let's put it. Actually, just wait one second. I'll just remove the PPT only. Which PPT is this? What's the name? Ratio.
GRE ratio proportion
Scroll.
practice set.
And which question is this? This one.
6. Yeah.
Let's put it here. So brand new car is 3354. 33504. I'll just put 33.5 because this 04 is quite insignificant.
Yeah.
Yeah, I'll work in thousands because any which ways, what is the question? A proportion. So if it's a proportion, it doesn't matter if I'm working with a large number or a smaller number. So I've first of all reduced this. We saved some time. What proportion of the total price of the car after tax is the untaxed price of the car? So what is the base? Is it total price or is it untaxed price? All answer
Mm.
choices are less than 1. So obviously the base will be higher.
Mm-hmm.
Yeah. So base will be higher, which means base is after tax, right? Higher price. And numerator is untaxed. This is what we want. Now what is untaxed? 33.5. And what is after tax? You add sales tax over it. So 33.5 into the factor. So the percentage is 8.275. So it becomes 108.275%, which means the factor is 1.08275, right? So 1.08275. So 1 by this is the answer. Point 9236. So definitely did not warrant 3 minutes. I think you probably got confused with the language here.
Yeah, the question was really confusing. I think I spent like 2 minutes trying to think what it meant.
Hmm. Okay. So this is the price pre-tax, untaxed. This is the tax. If you multiply these two, you'll get after tax, which is this.
Yeah.
That's what we have done here. And if you can see, as soon as you reduce the dimensionality of the problem, it becomes much more easier to do it. Otherwise, you have to type 33504. No need of doing that.
Mm-hmm.
I could have also taken 3.35 and made it even simpler.
So usually if you have a price, you have to assume that it's untaxed.
Yeah, I mean, because that's what it is here, because then the tax is given. And then you're being asked the
Okay.
proportion of total price after tax and untaxed.
Mhm.
Yeah.
Yeah.
I think you got confused whether it's untaxed or taxed.
Yeah.
Hmm. Bit vague this was,
Mm-hmm.
but this is untaxed.
Yeah.
What is the next question? Is this the last one or no? There's one.
No, there's
140.
2 more.
You got this?
140.
Let's check your answers.
Yeah.
Yeah, you got it. 25 seconds. Okay, good. Mark down by 25, another 10. Okay, so this is factors. Couldn't solve. Okay. So we have an exercise chart here for 10 weeks. Weight is being tracked here. Data is shown. Okay. By what percentage did his or her body weight decrease after 5 weeks of exercise? Okay, fifth week weight is this. Hmm. So what is the answer here? 6.5 divided by 130, right?
Mhm.
Answers are not matching.
Yeah.
Okay, and what is the second question? This did we get?
This one, the answers are matching. So I was a bit confused.
This one is matching, right? The second one.
Yeah.
So what percentage of the original weight did the exerciser weigh at the end? So that's 115 by... Yeah, it's pretty simple, straightforward.
Mhm.
Yeah. This is also correct. I'll just check these. What happened here?
Okay.
But your approach is right. Okay.
Mhm.
So let's go to today's chapter. So whenever you have a series of different operations on a set of numbers, the order to be followed is parentheses followed by exponents, followed by multiplication, division, addition, and subtraction.
Yeah.
Yeah. So for instance, this, we will solve the parentheses first and then division, which is answer is 2. Simple one. Here we will
Yeah.
first solve the division because that's higher in the pecking order. And then I'll add 2 to it. Yeah. So let's see this. What's this?
B.
Yeah. 5 into 9 minus 4 plus 3. This is 5. So 28. Okay. Simple.
Yeah.
This one. Such questions could be asked, by the way.
Mhm.
Simple ones to warm you up for the exam.
D.
Okay. Which one?
D.
Sure.
Um. Yeah.
Okay. All right. Next. Quant comparison.
B.
Which one?
B.
B, is it?
I think so.
Sure.
Yeah.
Okay. I will always try to confuse you, okay?
Oh,
So that you're sure. Always. Okay. So first
yeah.
of all, can I say both the numerators are the same actually?
Yeah.
So I need not solve. I'm sure you must have solved it.
I just
Solved A,
solved
you also
the
solved B.
first.
So if you observe, this 4 square is 2 raised to 4. And hence both the
Yeah.
numerators are the same. So all that I had to look was at the denominator. This is 9 and this is 8.
Mm-hmm.
So obviously B is greater than A.
Yeah.
Yeah. Okay. Obviously, I mean, this is convenient this in this question, but not always your numerator will be same.
Yeah.
Some time you could have saved, right? Some 5 odd seconds by
Mm-hmm.
the- by directly observing that numerators are the same. So just compare denominators.
Mm-hmm.
So whenever you have exponents, right, on both sides of a quant comparison, just check if the numerators are coming to the same. That means they're trying to check for denominators. They're checking your concept
Mm-hmm.
based on whether you're able to understand denominators. And here the calculations were simpler actually. Even if you calculated, you would have wasted 5 more seconds, probably. Slightly more. But if the operations are more complex, you can save some time by realizing that two entities can be same, especially the numerators.
Yeah.
All right. What is the value of x? I'm timing you also.
Five.
Sure.
Yeah.
Okay. Yes. So no explanations, right here? All good?
Yeah.
Okay.
But I calculated it out every single part. Is there a better way to do that or?
Yeah, I mean, see, this is a question which is a box question, which means no choices given.
Mhm.
So if there are no choices, then the only way is to solve. But here, this term becomes simpler, right? This is 18 minus 16. So this is 8. And this is minus 2x of minus 2.
Yeah.
Correct?
Hmm.
This is equal to 2. So can I say factor of 2 is common? So I'll just write 4x minus 2 is equal to 2 times 4 plus x. Yeah, so 2x
Yeah.
equal to 10 and x equal to 5. Yeah, there's no
Mm-hmm.
choice. You have to answer this.
Okay.
Yeah. But you can get rid of an extra 2 here.
Mm-hmm.
Divide both these by 2. Any which ways, it will not make too much of a difference. All right. Fraction.
Yeah.
So this was on order of operations. Now fraction operations. So in order to add and subtract fractions, so this is very basic. You know that if the denominators are the same, then we can directly add or subtract. Otherwise, we need to go to the LCM method. For instance, the denominators are different here. So we will always
Mm-hmm.
take LCM, 15,
Yeah.
and this will be 5x plus 3x, 8x by 15.
Yeah.
Okay. Now, this is fairly basic here. Multiplying fractions. I won't even get into this. Okay, let's simplify this. So I'll do it. So in the numerator, we have 12 as the LCM, which becomes 7 minus 3. And the denominator, we have 9 as the LCM. So that becomes 4 plus 3. So that's your answer. So 4 by 12 is 1 by 3 into, and division is 7 by 9. So that goes in the numerator. So 9 by 7. 3 by 7 is the answer.
Yeah.
Yes.
Mm-hmm.
So this, if flipped up, will flip your numerator and denominator. That's the only thing.
Yeah.
Okay. Quant comparison question. 2 by y is equal to 1 upon x plus 4. Which is greater, x or y? So how will we solve such kind of questions? Now this is a medium to hard difficulty level question. So first of all,
Do
you
you?
observe
Oh,
that there's a 2 here on the numerator.
yeah.
How can I make this as 2? This RHS, can I say multiply both numerator and denominator by 2?
Yeah.
So can I get so can I say we get, if we compare these two equations now, I mean this equation, both sides, y will be equal to 2x plus 8.
Mhm.
So now can you answer which is greater? Is it x or is it y?
Why?
Always.
Um.
So always take three values of x scenarios. Scenario number 1, take x greater than 0. So take
Mhm.
x equal to 1. Obviously, y will be bigger. Second scenario, take x equal to 0. So what will be y? 8. Again bigger.
Yeah.
Third scenario is x less than 0. So take x equal to say -1. So what will be y? 6.
6.
And if you take a large negative x, like -10, what will be y? Minus.
12.
So which is
Minus 12.
higher?
X.
So what is happening here?
D.
Yes, such a trick question. It seems so obvious, right? That okay, why
Yeah.
8 is added to 2x, so y should be bigger. But that's not the case. Never
Mhm.
assume anything on the GRE.
Yeah.
And see, whenever you're taking choices, right? Like I'm taking these scenarios. Within the scenarios, look at what I did with x less than 0. I took a small value of x and I took an obnoxiously large value of x compared to the small.
Yeah.
And then I checked whether it's working or not.
Mhm.
And had you taken x equal to -100, you would have realized that y is way more negative than x.
Mhm.
So can I say that the relationship breaks here?
Yeah.
So in all these first three cases, we had y greater than x, and here somewhere x is greater than y. So the
Mhm.
relationship breaks. So answer is cannot be determined.
Yeah.
Looks like such a harmless question.
Mhm.
So what is your learning through this?
You have to check different values of x that are negative and positive.
Yes. And even within the case,
Mhm.
so, so here there was no point in checking for x equal to 200, equal to 100 because we know it is always added by 8. On the positive side, there is no issue.
Mhm.
Always on the negative side, take a small value and take a very large value. So this is
Yeah.
the learning. So many students will look at, okay, we'll take a very easy value of x, like a small number, and assume that y is always greater than x. But that's not true.
Yeah.
Got it?
Mhm.
If I were to draw this on the diagram, how will it look like on the xy axis? How will you plot this line on the xy axis?
Mhm.
Should I think I'll do it on a fresh page. I don't want to clutter this. Y equal to 2x plus 8. I'm showing you why you need to be careful, and for that, if you know coordinate geometry well, it really helps you solve these problems accurately.
Yeah.
So if I were to plot this, I would need x and y coordinate. So can I say when I put x equal to 0, what is y?
8.
8. So can I say 0 comma 8 is one coordinate? And can I
Yeah.
say that will be 0 comma 8? Similarly, if
Mhm.
I put y equal to 0, what is x?
4.
-4.
Oh, -4.
Yeah. So the other coordinate is -4 comma 0. So -4 comma 0, can I say is in the second quadrant here?
Yeah.
-4 comma 0. So this is your line.
Yeah.
So this is the line y equal to 2x plus 8.
Yeah.
Yeah. So can I
Mhm.
say that this point is where you need to be careful, where it meets the x-axis.
Yeah.
And hence, if you take a value less than -4, it will flip.
Mhm.
X and Y will flip.
Yeah.
Got it?
Mhm.
So clearly what is happening, see, properly observe what is happening here. In the region towards the right of the y-axis, can I say this equation is giving you a head start of 8? Because when x is 0, y is 8. So
Yeah.
y is always greater than x towards the right. No problem here.
Mhm.
In this region, can I say x is negative, but y is positive. So y will again be greater than x.
Yeah.
But this is the region which is where it can flip, and that is beyond x equal to -4.
Yeah.
It could flip beyond this. Yeah. And that's where we need to be careful. And do you know why we need to be careful here? Because if you see the slope of this line, can I say y increases at twice the rate of x?
Yeah.
So when x is positive, no problem, y will increase more. But when x is going negative, y will go doubly the negative that rate. So
Yeah.
it's double negative rate for y. So if x is negative, y is degrowing twice,
Mhm.
which is why you need to be careful.
Yeah.
Yeah. So I'm showing this graphically so that you understand, but it's not important to do all this on the real
Mhm.
exam. What you need to know is this is only for your knowledge, by the way.
Yeah.
What you need to analyze is when you're given an equation like this, okay? Now, when x is positive, no problem, y will increase more than x because this rate of slope is twice. But when x
Yeah.
is negative, y will decrease at twice the amount.
Mhm.
And that's why you need to be careful. Which is why in my third case, which is when I was inspecting x less than 0, I took a small value of x and I took a large value of x, negative value, I mean.
Yeah.
I could have also taken 100, -100, to be sure that it's sufficiently large.
Mhm.
So you need to analyze what's happening. Can I say it's a, a play of slopes here? If x is
Yeah.
negative, y will be doubly negative because of the slope of 2. So can I say y is more sensitive than x?
Mhm.
If x is positive, no problem. Y will increase more. But if x is negative, then y is plunging more than x.
Mhm.
Yeah? So
Yeah.
this is how it looks.
Yeah.
It's a good question. Please star mark it.
Mhm.
And tough questions will be of this format. They will seem
Yeah.
harmless, but they are going to test you whether are you able to understand. So first of all, in this problem, you had to first understand how to set up the relationship between y and x, right?
Yeah.
That's the first thing. And of course, I did this method, you can also cross multiply and get y equal to 2x plus 8. It's the same thing.
Mhm.
Yeah. But then this was where it got tricky, especially in the third case, x negative. And that is because the slope. Similarly, any problem with y equal to minus 2x plus 8 also will become tricky.
Yeah.
Had the problem been y equal to x plus 8, then your answer would be that y is always greater than x.
Mhm.
Because the rate of change of y is same as x.
Yeah.
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 Okay. Next. Four roommates pooled their funds to buy a television for their apartment. Janice contributed 1/4. So J has 1/4. T has 1/6. L has 2/5. If the television costs 360, what was the fourth roommate share? So there's a fourth roommate, and we don't know the share. And the television is costing 360. Obviously, can I say the sum of the fractions should be equal to 1?
Mhm.
So we can find x.
Yeah.
So what will be x? So we can approximate. This is 0.25. This is 0.167. This is 0.4. So can I say x will be equal to what? 0.183, I think.
Yeah.
Yeah. So if x is 0.183, it's 18% of 360. So can I say roughly 20% of 360? So answer should be around 72, but below that. So the answer is 66, I think.
Mhm.
Yeah, 66 is the answer. Right?
Yeah.
So whenever you have fractions here, but you know that the sum total will always be 1. So if one fraction is unknown, you can find that. And the total is 360. So the share will be 360 into 0.183. Now we know
Mhm.
this will be roughly 20%.
Yeah.
So answer should be around 72, but slightly less than 72. So I'll choose 66.
Mhm.
So when you're short on time, this is how we approximate. We don't need to go to the calculator.
Yeah.
Okay.
Yeah.
Now, last thing for today is exponents. And this is the very important rule in exponents. We did this sometime back. A to the power b
Yeah.
into a to the power c is a to the power b plus c, right?
Mhm.
So what's this? 5 to the power
5
7.
equals 7.
And what's this?
Um,
3 is common, right? The base.
yeah.
Start adding up. 4x plus 2x
7x
plus
plus 2.
4 plus x minus 2. correct?
Yeah.
Yeah. Similarly, so that was multiplication. If you have division by the same base and the exponent, a to the power b divided by a to the power c becomes this. And this makes sense because a to the power b divided by this can be rewritten as a to the power b into a to the power minus c.
Mhm.
And you take the sum, it becomes b minus c. So nothing new in this rule. It's a follow-up of the first rule.
Yeah.
So this will be 6.
Mhm.
And what will this be?
X plus 1.
X plus 3. Okay.
Oh.
Right.
Oh, yeah.
Yeah. Correct. X plus 3.
Mm-hmm.
Right. One more rule. A to the power c into b to the power c. Now the bases are different. So these are different, but the powers are the same. The exponent is the same. So then you can multiply the bases and raise them by the same exponent. So this basically is 2 into 3 cube. So this is
Yeah.
6 cube. So that is 216. And how do we solve this? Both are raised to 4. So can I say we can multiply? Please do not make the mistake of adding inside. Bases
Mhm.
will always be multiplied.
Yeah.
It's very tricky, this one, when it contains variables.
Yeah.
Okay. And one more thing, if you have a to the power b and both are raised to c, exponent over exponent, it becomes base is the same and the exponents will be multiplied.
Yeah.
So 3 raised to 4, cube of that will be 3 raised to 12. And 7 to the power 2x raised to 4x will become 7 to the power 8x squared, right?
Yeah. Yeah.
And anything raised to the power 0 is 1. And you know how to flip it. A to the power minus
Mhm.
b can be written in the denominator as 1 upon a to the power b. So these are some of the rules. X raised to a into x raised to b will become x raised to a plus b. X by a divided by x by b becomes x to the power a minus b.
Yeah.
A raised to x into b raised to x becomes ab raised to x. Yeah, so these are some of the rules. And of course, a raised to x raised to y is a raised to xy.
Yeah.
So let's do this. So here the clue is that we know 3 is equal to 9. So 3 is fine, but 9 is equal to 3 square, right?
Yeah.
So we can rewrite this expression as 3 to the power 5 into 3 square of that divided by
Mhm.
3 square raised to 4, which is 9 raised to 4. So this becomes 3 to the power 5 into 3 to the power 4 divided by 3 to the power 8. So the answer is 3.
Yeah.
Yes.
Yeah.
Quant comparison, which one is higher, A or B? 10 seconds question.
Uh,
Time
A.
starts. Okay. Yes, A is higher. So this is 10 to the power minus 1. Obviously, this is greater than B. Okay. 20-second question.
X is A is higher.
X is what, 5?
X is 15.
Sure.
Yeah.
Yeah. X is 15. Absolutely. Hence, I said it's a less than 20-second question.
Mm-hmm.
So 4 to the power 5 equals to 4 to the power 20 minus x. You can compare these two now. So x
Mm-hmm.
becomes 15. Yes. Okay. 30-second question. Or not.
C.
C?
Yeah.
Sure.
Yeah.
Yes. So can I say here it was all raised to negative raised to negative, right?
Yeah.
So what is this expression equal to?
AB all squared.
So can I say this is nothing but a square b square raised to minus 1. So this becomes a square b square, right?
Yeah.
And same is the case with this ab raised to minus 2. So that becomes ab square, a square
Mm-hmm.
b square. Yeah, good.
Yeah.
I could have also directly multiplied exponents.
Yeah.
So that becomes a square b square. And this becomes also a square b square.
Mm-hmm.
Shortcut. Okay. Which is higher? 30 seconds.
Um, D.
D or B?
Yeah. D.
Sure.
Yeah.
And why is that?
Because X could be, if X is like 0.1 or something, if it's less than 1, then A would be smaller. But if it's greater than 1, then A would be greater.
Okay, so it's comparison of the exponents then.
Yeah.
So 5x and x plus 5. So it's a relationship between 4x and 5, which means it's a relationship between x and 5 by 4, correct?
Mm-hmm.
So which one is higher? A or B?
Um,
So can I say value below 5 by 4 will give you a different answer, and
yeah.
above 5 by 4 will give you a different answer. So scenario 1, x equal to 1. So 5x will be equal to 5 and x plus 5 will be equal to 6. So can I say this is greater? Scenario 2, x equal to 2. What is greater? 5x becomes 10 and x plus 5 becomes 7. So this is greater. So can I say the equation flips to the left and to the right of 5 by 4?
Mhm.
So that's like a boundary point. Below 5 by 4, b is greater than a, and above 5 by 4, a is greater than b.
Yeah.
And the reason is because if you look at 5x, can I say it will increase by 5 times the x? So obviously the rate of change of this will be higher as soon as x starts becoming a larger integer.
Yeah.
But if it's a fraction, then it's possible that since you're adding 5 to a fraction, x plus 5 is larger.
Yeah.
Yeah, so that's the logic behind it. And
Yeah.
also, I've told you how to find the boundary point here.
Mhm.
Comparing the exponents, and x will be 5 by 4. So to the left, answer will be different. To the right, it will be different.
Yeah.
Why are we doing this? So that we understand what ranges to take, what scenarios to take.
Mhm.
Otherwise, you might end up taking two scenarios, both on the same side. Like if you take x equal to half and x equal to 1, it will give you the same answer.
Yeah.
And then you will end up marking B, which is incorrect.
Mhm.
So hence you should know what is the left side and what is the right side, proper left and proper right to take.
Yeah.
Another choice is take a fraction and take a large number. I always do this.
Yeah.
Here, because x is greater than 0, right? So there's no point of a negative. It's not in the
Mhm.
domain of x. So I take x small and I take x very large.
Yeah.
Yeah, so that's how it works.
Yeah.
This one. So realizing that 81 is a power of 3, we can make things simpler for us. And even if you see the answer choices, everything is a power of 3. So clearly that also tells you that raise everything to the power of 3.
Yeah.
I mean by the base of 3, right? So
Mhm.
x will be 3 to the power 8 into 3 to the power 4 raised to 5. This is 3 to the power 8 into 3 to the power 20, 3 to the power 28. And y is what? 3 square raised to 7 and 3 cube raised to 12. So this is 3 to the power 14 into 3 to the power 36. And this is 3 to the power 50. So ultimately you need x into y, which is 3 to the power 28 into 3 to the power 50. So the answer is this. So all rules are being tested here, almost.
Mhm. Yeah.
Yeah, simple, right?
Mhm.
Okay. Radicals, what are these radicals? These are like roots of something, right? Some
Mhm.
of these could be rational, some could be irrational. Like root of 9 is rational because the answer is 3, but root of 5 is irrational. So the most important rule regarding rationals is this, regarding radicals is this. R into root of S into T into root of U. You can combine the roots together and you can combine the non-roots together. So RT into root of SU. Basically, it's the same rule. Remember this rule? A to the power x and B to the power x is equal to AB raised to x.
Yeah.
So can I say S is root S is S raised to half and U is S raised U raised to half. So when I multiply
Yeah.
these two, the exponent is the same. So I can do a product of the bases. So this is nothing but root of SU. So it follows from the exponent rule only.
Yeah.
Similarly, if you're dividing two radicals, the non-radical terms can separate out, and those within the same type of radical can be combined. So for instance, this can be written as 16 by 8 and root of 90 by 10, and this is 3. So the answer is 6 here.
Yeah.
Okay. Important rule. A raised to B by C. So the exponent is B by C. So this can be rewritten as A to the power B raised to 1 by C, can I say? And this is nothing but Cth root of A raised to B. So
Yeah.
how do I solve for this? 8 raised to 1 by 3. Can I write this as 2 cube raised to 1 by 3? And that becomes 2. Yes?
Yeah.
And how do I write this? 3x to the power 2 by 5. So I'll first square it. So it becomes 9x square to the power 1 by 5. So that is the fifth root of 9x square.
Yeah.
Great. Some two other rules. If you add and subtract radicals, you can club the constant terms together if the radicals are the same. So how will we solve the first one? So we collect all terms having same radicals. So these two will be collected together and these two. So 4 root 5 minus 3 root 5 will be root 5. And 3 root 2 minus root 2 will be 2 root 2.
Yeah.
Yeah. Similarly, your root 3y terms will be collected together and root 2r terms will be collected together.
Mhm.
Yeah.
Yeah.
Straightforward. Some
Yeah.
problems. Last 3-4 problems.
Mhm.
How do we solve this? Can I take everything under the root?
Yeah.
So 5 into 60 divided by 3. So it's root of 100, which is 10. So if you have the
Yeah.
same power everywhere, you can put all the terms under the same power. Yeah.
Mhm.
Next. Okay. How do we do this?
So you can multiply the root 2 and the root 6 to get root 12. And then you can simplify that to 4 times 3, and you can take out the 4. And then you'll have 2 root 3 plus 2. No, you'll have 4 root 3 plus 2 root 3 equals the 6 root 3.
Okay. Sure. Can I also write root 6 as root of 2 into 3?
Yeah.
And then root 2 will become 2. So this becomes 4 root 3 plus 2 root 3. So it becomes 6 root 3.
Yeah.
What you said is also possible. So 2 root 12 plus 2 root 3. Now root 12 can be written as root of 4 into 3. So root of 4 is
Mhm.
2. So this becomes 4 root 3 plus 2 root 3. Again, same answer.
Yeah.
Yeah. Which quantity is higher? 15 seconds. Time starts now.
It's the same thing.
Same thing, yes.
Yeah.
Yeah. So this, okay. So 2 root 3 by 6 becomes root 3 by 3, which is 1 by root 3, which is the same as this. Okay.
Mhm.
This is equal to what?
Um, 9.
9. So 27 is 3 cube raised to 2 by 3. 3 squares, 9. Now this one. So the clue for this one is whenever you have exponent minus exponent in the denominator or exponent plus exponent with
Yeah.
two different exponents, sorry, two different radicals, what you need to do is need to normalize it. For instance, if I have root A plus root B, two different radicals, I will just multiply it by this. So I'll just
Yeah.
flip the sign in the middle and multiply numerator and
Mhm.
denominator both by these. Similarly, if you
Yeah.
have 1 upon root A minus root B, we will multiply by root A plus root B on
Yeah.
both numerator and denominator.
Yeah.
Okay?
Mhm.
Which means this can be solved as numerator is root of 7x plus 3y divided by root of 7x minus root of 3y. Can I say I can multiply by the complement of this?
Yeah.
The complement is with a plus inside.
Mhm.
Now, when I look at the denominator, root A, okay, root A minus root B into root A plus root B. Can I say becomes root A square minus root B square?
Mm.
And that becomes A minus B, correct?
Yeah.
And that's what we will use in the denominator here. So the denominator becomes 7x minus 3y. And in the numerator we have root 7x plus root 3y into root of 7x plus 3y. Now, if you see your answers, it matches with this.
Yeah.
So that's your answer. So it's just the expansion of this bracket, right?
Yeah.
So these are some of the rules and examples on exponents and radicals.
Mhm.
And there are lots of practice questions. Some of these are hard
Mhm. Yeah.
and some are easy. So you can practice these. I think there are about 10 odd practice questions.
Mhm.
Yeah, and you can send your solved examples to me.
Yeah.
And I'll see you tomorrow.
Mhm.
Yes. Have in the
All
demo
right.
class, did we do the RC? I don't think we did RC, right?
In the demo class, RC.
We did sentence completion and statistics.
Yeah. Yeah.
Yeah, we've not done RC.
Mm.
Okay. So I'd like to do RC and introduce
Yeah.
the mapping structure to you
Mhm.
so that then you can start practicing some RCs with the maps. Okay, so
Yeah.
tomorrow we'll spend some time on RC.
Mhm.
All right.
Yeah.
Great. I'll be sharing all these with you soon.
Mhm.
And just finish the practice sets today, if possible.
Yeah.
All right. Any questions for
All
me?
right. No.
Sure.
Mhm.
Okay. All right. Take care.
You too.
Thank you.
Bye.
Bye. Bye.